Welcome to Milky Narratives. Tonight we'll step away from the rush of everyday life and drift into the deep, quiet ocean of space. Relax, breathe, and let the universe unfold around you, one star at a time. 1. The stars that refused to die. Some stars should not exist. According to everything we know about stellar evolution, they should have exhausted their fuel long ago, faded into darkness, and become little more than ancient remnants drifting silently through space. And yet, when astronomers point their telescopes toward certain regions of the cosmos, they find stars that seem to have ignored the rules. Stars that appear far younger than their surroundings. Stars that somehow continue shining when every prediction suggests they should already be dead. Tonight, as you settle into a comfortable position and allow the noise of the day to slowly drift away, we are going to explore one of the universe's most fascinating mysteries, the story of stars that refused to die. At first glance, stars may seem eternal. Night after night, year after year, they appear unchanged. The same constellations watched by ancient civilizations still hang above us today. The same stars that guided sailors across oceans continue to shine in the darkness. But stars are not immortal. Every star is living on borrowed time. Deep within each one, an invisible countdown is always running. A star exists because gravity and nuclear fusion are locked in a delicate balance. Gravity constantly tries to crush the star inward. Fusion pushes outward. As long as those forces remain balanced, the star survives. But eventually, the fuel begins to run low, and when that happens, the star must change. For massive stars, the process can be dramatic. They explode as supernovae. They leave behind neutron stars or black holes. Their deaths can briefly outshine entire galaxies. Smaller stars experience quieter endings. They slowly expand into red giants before shedding their outer layers and shrinking into white dwarfs. Either way, every star eventually reaches the end of its journey. Or at least, that is what astronomers once believed. Because hidden among ancient star clusters, researchers discovered something deeply puzzling. They found stars that appeared impossibly young. To understand why this was such a shocking discovery, we first need to visit some of the oldest neighborhoods in the universe. These places are called globular clusters. Globular clusters are enormous spherical collections of stars. Some contain hundreds of thousands, others contain millions. They orbit galaxies like ancient companions, surviving for billions of years. Many of them formed shortly after the universe itself was young. Some are nearly as old as the Milky Way. Imagine an entire city where every resident was born on exactly the same day. Everyone grows old together. Everyone ages at roughly the same pace. That is similar to how astronomers think about globular clusters. The stars within them formed around the same time. So when scientists examine these clusters, they expect to see stars of similar age. And for the most part, they do. Most stars inside these ancient systems appear exactly as expected. Old, dimmer, evolved, slowly approaching the final chapters of their existence. But then astronomers noticed something strange. Scattered among these elderly stars were brilliant blue stars. Bright, hot, energetic, young-looking. Stars that seemed completely out of place. It was as if someone had walked into a retirement community and discovered a group of energetic teenagers running through the streets. The discovery made very little sense. If the cluster was billions of years old, these stars should also be billions of years old. They should not appear young. They should not burn so brightly. And they certainly should not look as though they had only recently been born. Yet there they were. Astronomers eventually gave them a curious name: blue stragglers. The name itself reflects the mystery. These stars seemed to be lagging behind the normal process of aging. They appeared to be stragglers in the cosmic timeline. For decades, nobody knew exactly how they formed. Were they somehow younger than the other stars? Had new stars mysteriously formed inside these ancient clusters? Was there something fundamentally wrong with our understanding of stellar evolution? The answers would reveal one of the most fascinating survival stories in the cosmos. As observations improved, astronomers began noticing an important clue. Blue stragglers were often found in crowded regions where stars lived unusually close together. In these dense environments, stars sometimes interact with one another in ways rarely seen elsewhere. And occasionally, two stars can become partners. Binary systems are remarkably common throughout the universe. In fact, many stars are not alone. They orbit companions. Sometimes two stars dance around one another for billions of years. Sometimes they exchange material. And sometimes something extraordinary happens. Imagine two aging stars slowly orbiting each other. Neither has enough fuel remaining to maintain its youthful appearance. Both should gradually grow older. Both should eventually die. But if one star begins pulling material from the other, the situation changes dramatically. Fresh hydrogen, the fuel stars need most, can flow from one star into its companion. Suddenly, the receiving star gains new resources. Its nuclear furnace grows stronger. Its temperature rises. Its brightness increases. And from a distance, it begins to look young again. The star has not truly reversed time. It has not become young, but it has received enough new fuel to continue shining far longer than expected. In a sense, it has cheated death. Even more remarkable events can occur. In the crowded centers of globular clusters, stars occasionally collide. These collisions are extraordinarily rare on human timescales. But over billions of years, they happen. When two smaller stars merge together, they create a single larger star. The newly formed object contains more fuel and greater mass than either original star. The result can be a brilliant blue straggler, a star reborn from the union of two aging predecessors, a cosmic second chance. And as astronomers uncovered more examples, a fascinating picture emerged. The universe is far more creative than early theories imagined. Stars do not always follow neat, predictable paths. Some borrow fuel, some merge, some receive unexpected opportunities to continue shining. While the universe obeys physical laws with remarkable precision, those laws often allow surprising possibilities. Even in systems billions of years old, nature sometimes finds ways to extend a star's life. And perhaps that is part of what makes astronomy so endlessly captivating. The deeper we look, the more we discover that the cosmos is not merely a collection of objects. It is a collection of stories. Stories of survival. Stories of transformation. Stories of stars that seemed destined for darkness, but somehow found a way to keep their light alive. And as we continue our quiet journey tonight, we will discover that blue stragglers are only the beginning. Because elsewhere in the universe, there are stars whose lifetimes stretch far beyond anything humans once thought possible. Stars that may continue shining long after our sun has vanished. Stars that could illuminate the darkness for trillions upon trillions of years. The story of stars that refuse to die is much larger than we once imagined. And in the vast silence of the cosmos, their ancient light is still waiting to be explored. 2. The planets that outlived their suns. What happens to a planet after its star dies? At first, the answer seems obvious. The star disappears. The warmth vanishes. The light fades. And the planets that once circled it are left frozen in darkness. End of story. But the universe rarely follows the simplest path. Because as astronomers have looked deeper into the cosmos, they have discovered something surprising. A star's death is not always the end of a planetary system. Sometimes it is merely the beginning of an entirely new chapter. A quieter chapter. A darker chapter. But one that may last far longer than the star itself. Tonight, we continue our journey through the hidden universe by exploring worlds that survived the death of their suns. Planets that watched their stars die. Planets that endured cosmic catastrophes. Planets that may still be drifting through the darkness, billions or even trillions of years later. And in some cases, these worlds may outlive nearly everything else around them. To understand how this is possible, we must first think about the future of our own solar system. Right now, the sun appears permanent. Every morning it rises, every evening it sets. For all of human history, it has been the reliable center of our existence. But the sun is not immortal. Like every star, it is living on borrowed time. Deep inside its core, hydrogen atoms are continuously being fused into helium. This process releases enormous amounts of energy. That energy pushes outward against gravity and keeps the sun stable. Yet the supply of hydrogen is finite. Slowly, very slowly, the fuel is being consumed. Fortunately for us, there is no immediate danger. The sun still has roughly 5 billion years of life remaining. 5 billion years. A span of time so vast that every human civilization that has ever existed occupies only a tiny fraction of it. But eventually, the countdown will reach its final stages. And when it does, the sun will begin to change. It will swell, grow brighter, expand into a red giant. Its outer layers will stretch outward through the solar system. Mercury will almost certainly disappear. Venus will likely follow. The fate of Earth remains uncertain, but even if our planet escapes direct engulfment, its oceans will vanish long before then. Its atmosphere will be destroyed. Its surface will become unrecognizable. The familiar solar system we know today will cease to exist. For any observers watching from afar, it might seem like the complete destruction of an entire planetary family. But surprisingly, not every planet is destined to perish. Far beyond Earth's orbit lie the giant worlds: Mars, Jupiter, Saturn, Uranus, Neptune, and many of them may survive. The transformation of the sun will be violent by planetary standards, but it will not necessarily eliminate every object orbiting it. Instead, something stranger may happen. As the sun ages, it will begin shedding enormous amounts of mass. Its outer layers will drift into space. Over hundreds of thousands of years, the star will lose a significant portion of its material. And when a star loses mass, its gravitational grip weakens. Imagine spinning a ball attached to a string. If the force holding the ball weakens, the ball moves farther away. A similar process happens with planets. As the sun becomes lighter, surviving planets gradually drift outward. Their orbits expand. The solar system slowly stretches. The planets escape neither gravity nor destruction. They simply move farther from the dying star. Eventually, the sun will cast off its final outer layers. A glowing shell of gas will expand through space. Astronomers call this a planetary nebula. Despite the name, planetary nebulae have nothing to do with planets. Early observers merely thought they looked vaguely planet-like through primitive telescopes. At the center of this glowing cloud, the remains of the sun will be exposed. The enormous star that once dominated the solar system will shrink to roughly the size of Earth. A white dwarf, tiny, dense, and slowly cooling. The sun will no longer generate energy through fusion. Its days as a true star will be over. Yet the surviving planets will still be there, still orbiting, still following paths established billions of years earlier. Imagine standing on one of those distant worlds. The bright yellow sun of Earth's skies would be gone. In its place would hang a small white point of light, brilliant at first, then gradually dimming over unimaginable ages. The star would be dead, but the planets would remain. And this is not merely speculation. Astronomers have already discovered evidence that such systems exist. Around distant white dwarfs, researchers have found signs of planetary debris, fragments of worlds, asteroids, and perhaps even intact planets. Some observations suggest that entire planetary systems can survive stellar death. Others reveal worlds orbiting astonishingly close to white dwarfs, worlds that somehow endured events once thought impossible to survive. One particularly fascinating discovery involves planets found around pulsars. Pulsars are among the strangest objects in existence. They are rapidly spinning neutron stars, the collapsed remnants of massive stars that exploded as supernovae. These explosions are among the most violent events in the universe. For years, astronomers assumed no planets could survive such catastrophes. Then came an extraordinary surprise. In the early 1990s, astronomers discovered planets orbiting a pulsar, the first confirmed exoplanets ever found. The discovery shocked the scientific community. How could planets exist around something born from a stellar explosion? Were these ancient survivors, or had entirely new worlds somehow formed afterward? Even today, astronomers continue investigating those questions. But regardless of their origin, they revealed an astonishing truth. Planetary systems are more resilient than anyone once imagined. Stars may die, explode, collapse, transform, yet worlds can sometimes endure. In fact, the future may belong to planets rather than stars, because stars burn fuel. Planets do not. Stars have limited lifespans. planets can persist for vastly longer periods. Long after stellar fires fade, planets may continue orbiting the remnants left behind. Some frozen, some shattered, some perhaps warmed by hidden internal heat. And among the most fascinating possibilities are the worlds that possess deep underground oceans. Even if sunlight disappears completely, geothermal energy can continue warming hidden seas beneath thick layers of ice. We already see hints of this in our own solar system. Moons like Europa and Enceladus contain subsurface oceans protected beneath frozen crusts. These hidden waters may survive independent of sunlight. If similar worlds exist elsewhere, then some planetary environments could continue existing long after their stars have died. Life, if it ever emerged there, might not notice the loss immediately. Entire ecosystems could remain hidden beneath frozen surfaces while darkness reigns above. It is a remarkable thought, a dead star overhead, an endless night sky. Yet beneath kilometers of ice, liquid oceans still quietly moving in the dark. The universe often reminds us that survival takes many forms. We tend to think of stars as the main characters of cosmic history, the bright actors commanding the stage. But perhaps planets are the quieter survivors, the witnesses who remain after the performance ends. Because when a star dies, its story concludes. Yet the worlds it leaves behind may continue their journeys for trillions of years, orbiting silently, remembering ancient suns, carrying the history of vanished solar systems into a future so distant that even most stars will be gone. And as we continue our journey tonight, we will discover that some of those surviving worlds do not orbit dead stars at all. Some travel alone, wandering through interstellar darkness with no sun to guide them, silent planets drifting between the stars. 3. The loneliest objects in the universe. There are places in the universe so lonely that the word isolation almost loses its meaning. Not empty planets orbiting distant stars, not forgotten asteroids drifting beyond the edge of a solar system, but entire worlds, ancient stellar remnants, and wandering cosmic bodies traveling through darkness with no sun above them, no neighboring planets beside them, and no destination waiting ahead. If one of these cosmic wanderers could somehow think, it might spend trillions of years crossing the galaxy without ever seeing another star grow noticeably larger in its sky. 1 trillion years. Not centuries, not millennia. Not even the entire age of our universe. A time span roughly 70 times longer than everything that has happened since the Big Bang. And throughout that unimaginable journey, the darkness would remain almost unchanged. Tonight, as we continue exploring the forgotten survivors of the cosmos, we arrive at some of the loneliest objects nature has ever created. Worlds without suns. Stars without companions, ancient travelers wandering through an ocean of darkness so vast that even light struggles to bridge the distances involved. The universe often feels crowded when viewed from Earth. On a clear night, thousands of stars fill the sky. Modern telescopes reveal billions of galaxies. Each galaxy contains billions or even trillions of stars. Every direction appears filled with cosmic structures. But this impression can be misleading. The universe is not primarily made of objects. It is primarily made of space, empty space, and the scale of that emptiness is difficult for the human mind to grasp. Imagine shrinking the sun to the size of a marble. Earth would become a tiny grain of sand orbiting several meters away. Jupiter would be much farther still, and the nearest star, in this scale model, it would sit hundreds of kilometers away. Everything between would be almost entirely empty. This vast separation exists everywhere throughout the cosmos. Stars are not packed together. Galaxies are not tightly clustered. Even galaxies themselves are separated by enormous voids, and sometimes gravity creates travelers that become detached from everything. One of the most fascinating examples is the rogue planet, a world with no parent star, a planet that wanders alone through interstellar darkness. Astronomers once assumed planets formed around stars and remained there forever. Then, evidence began accumulating that some planets had escaped. Violent gravitational interactions can occur during the early stages of planetary formation. Massive planets tug on smaller worlds. Close encounters destabilize orbits. Over millions of years, entire planets can be thrown completely out of their solar systems. Like cosmic slingshots, giant worlds may hurl their smaller neighbors into interstellar space. The ejected planet leaves forever. No sunrise, no sunset, no seasons, only darkness. And yet, these lonely worlds may be surprisingly common. Some estimates suggest there could be billions of rogue planets drifting through the Milky Way, perhaps even more rogue planets than stars. Think about that for a moment. For every familiar sun shining overhead, there may be multiple unseen worlds wandering silently through the dark. Most would be impossible to see directly. Without a nearby star, they reflect almost no light. They become nearly invisible, ghost planets moving through the galaxy unnoticed. Yet despite their loneliness, some of them may not be entirely frozen. Deep beneath their surfaces, hidden sources of heat can remain active. Radioactive elements within planetary interiors slowly decay. Residual heat from formation can persist for billions of years. Thick atmospheres may trap warmth. Subsurface oceans may survive beneath vast shells of ice. Even without sunlight, some rogue planets could maintain pockets of liquid water, tiny islands of warmth drifting through endless night. It is one of the strangest possibilities in modern astronomy. Life, if it existed there, might never see a star. Imagine an ocean buried beneath kilometers of ice, creatures evolving in darkness, generations living and dying beneath frozen ceilings, entire ecosystems unaware that galaxies shine beyond their hidden world. To them, darkness would not be unusual. Darkness would simply be reality. And yet, rogue planets are not necessarily the loneliest objects of all. Some stellar remnants may experience even greater isolation. Consider a white dwarf that has lost its planetary system, a dead star wandering alone through space. White dwarfs are extraordinarily long-lived. After a star like our Sun dies, its remaining core continues cooling for trillions of years. Slowly, patiently, almost imperceptibly. If such an object were ejected from its galaxy or cast into an especially empty region of space, it might spend periods of time longer than the current age of the universe without encountering another significant object. Its sky would be nearly empty. Its faint glow would illuminate nothing. It would simply drift, an ancient ember carried by gravity through the darkness. Even stranger are the stars that inhabit the outskirts of galaxies. Not every star remains close to the crowded galactic disk. Some are launched outward through gravitational encounters. Others belong to vast stellar halos surrounding galaxies. These stars can exist hundreds of thousands of light years from their nearest neighbors. If you stood on a hypothetical planet orbiting one of these isolated stars, the night sky would look nothing like Earth's. There might be no bright constellations, no dense band of the Milky Way, no familiar star fields. Instead, the darkness would dominate almost everything. The nearest visible stars could appear as faint points scattered sparsely across the heavens. The universe would feel almost abandoned. And yet these lonely stars are still part of galaxies. The true champions of cosmic isolation may be found elsewhere. Beyond galaxies lie enormous cosmic voids, the largest structures of emptiness known. These voids span hundreds of millions of light years. Inside them, galaxies become incredibly rare. If a lone object somehow found itself deep within one of these regions, it would experience isolation on scales difficult to imagine. The nearest galaxy might be tens of millions of light years away. Light itself would require millions upon millions of years to travel between neighbors. The night sky would be astonishingly dark, not because stars no longer exist, but because they are unimaginably far away. These cosmic voids reveal something profound about the universe. Its defining feature is not matter, it is emptiness. Matter forms islands, stars form islands, galaxies form islands. Everything we know exists as scattered oases surrounded by vast oceans of nothing. And as the universe continues expanding, that isolation will only increase. Galaxies are already moving apart. Over trillions of years, distant galaxies will slip beyond observable horizons. Future civilizations may see only their local galaxy and nothing else. The broader cosmos will gradually disappear from view. the universe itself will become lonelier. One by one, cosmic neighbors will vanish beyond reach. One by one, the lights will fade. Yet there is something strangely beautiful about these solitary wanderers. They remind us that survival does not always require companionship. Some worlds continue their journeys alone. Some stars shine without witnesses. Some ancient remnants drift through darkness longer than entire civilizations can imagine. The universe is filled with spectacular explosions and brilliant galaxies, but it is also filled with quiet endurance, silent travelers crossing impossible distances, patient survivors moving through endless night. And among all the cosmic wanderers we have discovered, some may be carrying secrets even stranger than loneliness itself. Because not every ancient survivor is a planet. Not every survivor is a star. Some are objects so old, so faint, and so unusual that astronomers almost never see them at all. And those hidden survivors may tell us a story stretching far deeper into cosmic time than we have explored so far. If tonight's journey through the universe is helping you relax, consider subscribing so we can continue exploring these forgotten cosmic survivors together. 4. Oceans waiting in eternal darkness. Some oceans may outlive entire civilizations. Some may outlive mountains, continents, and even the stars that once illuminated their worlds. Hidden beneath layers of ice and darkness, they may continue existing long after the surfaces above them have become frozen wastelands. Tonight, as our journey through the forgotten survivors of the cosmos continues, we descend beneath frozen crusts into some of the most extraordinary places nature may have ever created. Not oceans beneath blue skies, not seas warmed by sunlight, but vast hidden worlds of liquid water concealed beneath eternal darkness. Places where life could potentially survive for billions of years without ever seeing a sunrise. Places that may remain alive long after surface worlds become silent and dead. When most people imagine an ocean, they picture Earth, rolling waves, moonlit coastlines, sunlight penetrating clear water, the familiar relationship between sea and sky. Yet Earth's oceans may represent only one version of what an ocean can be. Across the solar system and perhaps throughout the galaxy, many oceans may never touch open air. Instead, they exist beneath immense shells of ice, invisible from space, hidden from direct observation, protected from the hostile environments above. One of the first clues came from a small moon orbiting the giant planet Jupiter, a world known as Europa. At first glance, Europa appears lifeless. Its surface is covered by bright ice, stretching endlessly in every direction. Temperatures remain far below freezing. Sunlight reaching Jupiter is already weak compared to Earth. At Europa, conditions seem utterly hostile. Yet appearances can be deceiving. Detailed observations revealed something remarkable. Europa's icy shell is crisscrossed by fractures, ridges, and strange patterns that suggest movement beneath the surface. Scientists gradually realized that a vast global ocean may exist underneath. Not a small underground lake, an entire ocean. A world-spanning sea hidden beneath kilometers of ice. And this ocean may contain more water than all of Earth's oceans combined. Imagine standing on Europa. Above you, a black sky. Far away, Jupiter hanging overhead like a giant striped world. Beneath your feet, an icy crust stretching downward for many kilometers. And below that frozen barrier, an ocean larger than anything humanity has ever known. Dark, silent, ancient, waiting. The existence of such oceans initially seemed surprising. Without sunlight, how could liquid water survive? The answer lies in gravity. Europa is constantly stretched and squeezed by Jupiter's immense gravitational pull. As the moon travels through its orbit, tidal forces flex its interior. That flexing generates heat. The process is similar to repeatedly bending a metal wire. Energy transforms into warmth. Over immense timescales, this heating may be sufficient to prevent the hidden ocean from freezing solid. In effect, gravity itself becomes the source of energy, no sunlight required. And Europa is not alone. Another moon, even larger and perhaps even more mysterious, may contain an enormous hidden ocean as well. Ganymede. the largest moon in the solar system, larger than the planet Mercury. Beneath its frozen surface may lie multiple layers of buried oceans separated by different forms of ice, like a cosmic layer cake. Ocean, ice. Ocean, ice. Ocean. Entire worlds hidden inside worlds. Then there is Enceladus, a tiny moon orbiting Saturn, far smaller than Europa, far smaller than Earth. Yet one of the most exciting places in the solar system, because Enceladus does something extraordinary. It sprays its hidden ocean directly into space. Gigantic geysers erupt through fractures near its south pole. Plumes of water vapor, ice particles, and organic compounds shoot hundreds of kilometers above the surface. Spacecraft have flown through these plumes and sampled material originating from the hidden ocean below. The results were astonishing. Complex organic molecules, chemical ingredients associated with potentially habitable environments, evidence suggesting hydrothermal activity deep beneath the ocean floor. On Earth, hydrothermal vents support entire ecosystems. No sunlight reaches these environments. Instead, life draws energy from chemical reactions occurring around hot, mineral-rich vents. Some scientists wonder whether similar conditions could exist within Enceladus. If so, darkness would not necessarily mean lifelessness. Life on Earth may offer an important lesson. For most of human history, we assumed sunlight was essential for all ecosystems. Then, explorers discovered thriving communities around deep-sea hydrothermal vents. Giant tube worms, strange crustaceans, entire biological worlds sustained without photosynthesis, without sunlight, without any connection to the surface. That discovery transformed our understanding of habitability. It suggested that life might survive anywhere liquid water, energy, and chemistry come together, even beneath frozen crusts, even in perpetual darkness, even on worlds orbiting distant stars, or perhaps on worlds orbiting no stars at all. Remember the rogue planets from our previous journey? The lonely wanderers drifting through interstellar darkness. Some theoretical studies suggest that large rogue planets could retain hidden oceans beneath thick ice layers for billions of years, despite receiving no starlight whatsoever. Internal heat could remain trapped below insulating ice, creating isolated pockets of liquid water. Imagine such a world. No sunrise, no sunset, no visible star in the sky. Only endless darkness stretching across the heavens. Yet beneath the frozen exterior, an ocean quietly survives. Life, if it emerged there, might never know that galaxies exist, never know that stars shine, never know that an entire universe of light surrounds its hidden world. Its entire reality would consist of water, darkness, chemistry, and time. And time is perhaps the most remarkable part of this story. These hidden oceans may survive for astonishing lengths of time. Earth's surface environment changes constantly. Continents drift, climates shift, species evolve and disappear. Asteroid impacts occur. Stars gradually brighten. Surface conditions can be unstable. But deep underground oceans are protected, shielded from radiation, shielded from impacts, shielded from many cosmic catastrophes. In some cases, they may remain stable for billions of years, long enough for extraordinary evolutionary journeys to unfold, long enough for entirely separate biological histories to emerge, long enough for civilizations, if such things are possible, to potentially rise and fall beneath frozen skies. And when we look even farther into the future, hidden oceans may become increasingly important. Billions of years from now, Earth itself will eventually become less hospitable. The sun will grow brighter, surface temperatures will rise, the familiar biosphere may disappear. Yet elsewhere, buried oceans could continue enduring, protected beneath ice, protected from stellar evolution, protected from the chaos of changing worlds. They may become some of the last refuges for liquid water in aging planetary systems, quiet survivors carrying warmth into the distant future. There is something profoundly comforting about that idea. While stars evolve, while planets change, while galaxies slowly drift apart, some oceans simply endure, hidden from view, patiently waiting beneath frozen ceilings, their waves moving in darkness, their chemistry continuing uninterrupted, their secrets preserved beneath layers of ancient ice. And perhaps somewhere far beyond our solar system, one of those hidden oceans contains something even more remarkable than water. Perhaps it contains life that has never seen the stars, life that has spent billions of years evolving beneath eternal darkness. Life waiting quietly beneath the ice while the universe changes overhead. Because some of the most fascinating survivors in the cosmos may not be planets or oceans at all. They may be ancient forms of life, persisting in places where almost no one would think to look. 5. The ancient stars older than the Milky Way. There is something wonderfully strange about looking up at the night sky. Most of the stars we see appear timeless, steady, unchanging, permanent. They seem like eternal fixtures hanging above us, shining night after night as they have for countless generations. Yet every star has a birthday. Every star was born at a specific moment in cosmic history, and some of those birthdays occurred so long ago that they take us almost back to the beginning of everything. Tonight we continue our journey among the universe's great survivors by searching for some of the oldest objects that still shine. Ancient stars so old that they may have existed before our galaxy became what it is today. Stars that have witnessed nearly the entire history of the cosmos. Stars that have survived while billions of others vanished. And perhaps most remarkable of all, stars that still shine above us tonight. When astronomers first began studying the ages of stars, they discovered something surprising. The universe itself has a finite age. According to modern measurements, the cosmos is approximately 13.8 billion years old. That number is almost impossible to fully comprehend. If every second represented an entire year, you would need more than 400 years simply to count to 13. 8 billion. Yet despite this immense age, some stars appear to have formed astonishingly early. Only a few 100 million years after the Big Bang. At that time, the universe looked nothing like it does today. There were no spiral galaxies, no Milky Way, no Earth, no Sun, no planets. The cosmos was still emerging from its infancy. The first generations of stars were beginning to ignite. Darkness was slowly giving way to light. And somewhere during that ancient era, a handful of stars may have been born that are still alive today. To understand why this is remarkable, we need to consider how stars age. Massive stars live fast and die young. The largest stars burn through their fuel at extraordinary rates. They shine brilliantly, they explode spectacularly, but they often survive only a few million years. In cosmic terms, that is barely an instant. Smaller stars live much longer. Because they consume fuel slowly, they can continue shining for billions or even trillions of years. The smaller the star, the longer its life may be. This simple fact creates an extraordinary possibility. If a small enough star formed near the dawn of cosmic history, it might still exist today, quietly shining after nearly 14 billion years, like a candle that has somehow survived since the beginning of time. Astronomers have spent decades searching for such ancient survivors, and they have found some fascinating candidates. One famous example is HD 140283, often nicknamed the Methuselah star. The nickname comes from the biblical figure associated with extreme age. For good reason. This star appears to be among the oldest known stars in our region of the universe. Its estimated age approaches the age of the universe itself. For a time, measurements even suggested it might be older than the universe. Fortunately, improved observations resolved that paradox. The star is not older than the cosmos, but it remains incredibly ancient, a true relic from cosmic history. Imagine standing on a hypothetical planet orbiting such a star. You would be looking at a sun that was already ancient before Earth existed, ancient before our solar system formed, ancient before the Milky Way fully developed its familiar spiral structure. Its light would represent a direct connection to one of the earliest chapters in cosmic history. Yet perhaps even more fascinating than their ages is what these ancient stars contain, or rather, what they do not contain. Modern stars are rich in heavy elements: carbon, oxygen, iron, silicon, gold. These elements were forged inside earlier generations of stars. Every time a massive star died, it enriched the surrounding universe. Future stars inherited those materials. As a result, younger stars contain greater amounts of heavy elements. Older stars contain fewer. This allows astronomers to use chemical composition as a kind of cosmic clock. A star with very few heavy elements likely formed before many stellar generations had lived and died. It is like finding an ancient fossil buried deep within Earth's geological layers. Its composition reveals its age. Its chemistry preserves history. Some of the oldest stars known contain only tiny traces of heavy elements. They formed when the universe was still chemically young, when most of the cosmos consisted almost entirely of hydrogen and helium. In a sense, these stars are living archaeological records, time capsules preserving conditions that existed billions of years ago. And their existence tells us something profound. The universe remembers. Not through books, not through monuments, not through civilizations, but through matter itself. Every ancient star carries evidence of the era that created it, a permanent record written into its atoms. The search for these stellar survivors has also revealed something unexpected about the Milky Way. Our galaxy did not simply appear all at once. Instead, it grew gradually. Smaller galaxies merged together over billions of years. Stars from those ancient systems became incorporated into the growing Milky Way. Some of the oldest stars we observe today may actually have originated inside long-vanished dwarf galaxies. Their original homes disappeared billions of years ago, yet the stars themselves survived. Imagine that for a moment. A galaxy forms. Generations of stars are born. Billions of years pass. The galaxy collides with another. Its structure is torn apart. Its identity vanishes. Its stars scatter across a larger system. Everything changes. Everything except the stars themselves. They continue shining, carrying memories of worlds that no longer exist. In this way, ancient stars become survivors not only of time, but also of cosmic transformation. Entire galaxies may come and go around them, yet they remain patient, silent, enduring. And there may be even older stars still waiting to be discovered. Astronomers continue searching for what are called population 3 stars. These are hypothetical first-generation stars, the very first stars ever formed after the Big Bang. Unlike later stars, they would have contained almost no heavy elements at all, pure hydrogen and helium, the original ingredients of the cosmos. Most models suggest these first stars were massive and died long ago, but some scientists wonder whether smaller examples might have existed. If any survived, they would represent the oldest stars in existence, true witnesses to the universe's first dawn. So far, none have been conclusively identified. Yet the search continues, because somewhere in the darkness, one of these ancient survivors might still shine, waiting to be found, waiting to tell us what the universe looked like before galaxies filled the heavens. And there is something deeply comforting about these stars. Human lives are brief. Civilizations rise and fall. Languages change. Nations appear and disappear. Even mountains eventually erode away. Yet these stars endure across timescales so vast that human history becomes almost invisible by comparison. Some were already old when Earth formed. Some may continue shining long after humanity is gone. They connect the present moment to the earliest ages of existence, a bridge stretching across nearly the entire lifetime of the universe. Tonight, somewhere above your head, ancient starlight is crossing space. Photons that left their stars years, centuries, or even millennia ago are arriving at your eyes. And among those countless distant suns may be a few extraordinary survivors, stars that remember a younger universe. Stars that formed before the Milky Way became the galaxy we know today. Stars that have quietly endured while cosmic history unfolded around them. And as our journey continues, we will discover that some survivors are even stranger. Because while ancient stars preserve the memory of the past, there are entire worlds that may continue surviving far into the unimaginable future of the cosmos. 6. The galaxies that escaped destruction. There is a common image many people carry in their minds when they think about galaxies. Great spirals colliding, stars thrown across space, titanic cosmic crashes unfolding over billions of years. And to be fair, that picture is not entirely wrong. The universe is full of collisions. Galaxies merge constantly. Some encounters are gentle, others are violent enough to completely transform both participants. Throughout cosmic history, countless galaxies have been torn apart, absorbed, reshaped, or erased altogether. Entire stellar civilizations, if any ever existed within them, would have watched their skies slowly change as neighboring galaxies drifted closer and closer until they eventually became one. Yet amid all this chaos, some galaxies managed to survive. Not because they were stronger, not because they were larger, but because they happened to follow quieter paths through cosmic history. Tonight we explore these unlikely survivors, the galaxies that escaped destruction, the islands of stars that somehow avoided the fate that overtook so many others. And in doing so, we may discover something unexpected about survival itself. To understand these cosmic survivors, we first need to appreciate just how crowded the young universe once was. Today, galaxies are separated by immense distances. The nearest large galaxy to the Milky Way is the magnificent Andromeda Galaxy. Even though it is our nearest major galactic neighbor, its light still requires more than 2 million years to reach us. That seems unimaginably far, but in the early universe, things were different. Everything was closer together. Gravity had less distance to overcome. Galaxies interacted more frequently. Mergers occurred far more often. Astronomers sometimes describe the young universe as a bustling city compared to the quieter suburbs we inhabit today. Back then, galaxies were constantly encountering one another. Some were swallowed whole, others merged repeatedly. Small galaxies often disappeared entirely inside larger ones. Many of the majestic spiral galaxies we see today are actually the products of countless ancient collisions. Our own Milky Way is no exception. Hidden within its structure are clues that reveal a complicated history of mergers, stretching back billions of years. Stars from ancient galaxies still orbit inside the Milky Way today. They are immigrants from systems that no longer exist. Their original homes vanished long ago, yet their stars survived. In a sense, pieces of those lost galaxies remain scattered throughout the galaxy we call home. But not every galaxy experienced such a dramatic fate. Some managed to avoid the busiest regions of the universe. Some formed in quieter neighborhoods, and because of that, they survived. One fascinating example involves dwarf galaxies. These tiny galaxies contain only a fraction of the stars found in larger systems. Some possess just a few million stars compared to the hundreds of billions found in the Milky Way. At first glance, dwarf galaxies seem fragile, easy prey for larger neighbors, and many certainly were. Yet some survived precisely because they remained small and isolated. They drifted through the cosmos unnoticed, too distant to be consumed, too insignificant to attract attention. While giant galaxies battled and merged, these tiny systems quietly continued their existence. Billions of years passed. Empires of stars rose and fell around them, yet they endured. There is something strangely beautiful about that. The largest structures are not always the longest lived. Sometimes survival belongs to those who avoid the struggle altogether. Astronomers have discovered dwarf galaxies whose stars are incredibly ancient. Some appear to have experienced very little change for most of cosmic history. They resemble living fossils, galactic time capsules preserving conditions that existed near the dawn of the universe. Studying them allows scientists to glimpse what galaxies looked like billions of years ago. It is like finding an untouched ecosystem preserved from another age. A rare survivor that escaped the transformations affecting everything around it. And then there are galaxies hiding in cosmic voids. The universe is not evenly filled with matter. Instead, it resembles an enormous web. Galaxies gather along vast filaments stretching across unimaginable distances. Between these filaments lie enormous empty regions called cosmic voids. Some voids span hundreds of millions of light years. They are among the emptiest places in existence. Galaxies living inside these voids experience a very different life from those in crowded regions. They have fewer neighbors, fewer interactions, fewer collisions. Their histories unfold more slowly. While galaxies in dense clusters repeatedly merge and evolve, void galaxies often remain relatively undisturbed. Some have spent billions of years growing in isolation. Imagine living on an island so remote that no visitors arrive for thousands of years. Now expand that idea to cosmic scales. A galaxy drifting alone through hundreds of millions of light years of emptiness. Its stars rising and setting beneath skies almost entirely free of neighboring galaxies. Its evolution proceeding in remarkable solitude. These galaxies may represent some of the quietest places in the entire universe. And yet, perhaps the most extraordinary survivors are galaxies that endured despite repeated attempts at destruction. Astronomers have observed galaxies stripped of gas, galaxies battered by close encounters, galaxies stretched by tidal forces, galaxies partially consumed by larger neighbors. Somehow they continue existing, not unchanged, but alive. The universe rarely grants perfect survival. Most survivors carry scars. The same is true for galaxies. Their histories remain written across their structures. Streams of stars extending into space, distorted spiral arms, unusual stellar populations. These features tell stories of ancient struggles, evidence of catastrophes that failed to completely erase them. In fact, the Milky Way itself may be considered one of these survivors. Over billions of years, our galaxy has consumed numerous smaller companions. It has endured close encounters. It has evolved through repeated interactions, and yet it remains recognizable as a spiral galaxy. Its disk still turns. Its stars still orbit. Its structure remains intact, at least for now. But even the Milky Way's survival has an expiration date, because approximately 4 billion years from now, something remarkable will happen. Andromeda is approaching us. Slowly, inexorably, the two giant galaxies are moving toward one another. Not because they are enemies, not because they are chasing each other, simply because gravity demands it. When the encounter finally occurs, the result will not be a violent explosion. Individual stars are so far apart that direct collisions will be rare. Instead, the galaxies themselves will gradually merge. Their shapes will distort, their structures will transform, and eventually a new galaxy will emerge from the union. The Milky Way will not exactly survive. Neither will Andromeda. Both will cease to exist in their current forms. Yet their stars will continue onward. A reminder that destruction and survival often occur simultaneously in the universe. Forms disappear, matter remains. Identities fade, stars endure. Perhaps that is the deeper lesson hidden within these cosmic survivors. Nothing remains unchanged forever. Not stars, not galaxies, not even the largest structures in existence. Yet survival does not always mean remaining exactly as you were. Sometimes survival means adaptation, transformation, persistence through change. The galaxies that escaped destruction are not necessarily untouched. Many bear the marks of ancient encounters. Many have changed dramatically, but they continue, still shining, still evolving, still carrying their ancient populations of stars across the darkness. And somewhere within those distant islands of light, suns are rising above alien worlds. Ancient starlight continues crossing intergalactic space. Entire cosmic histories unfold beyond our sight. Quiet reminders that even in a universe shaped by collisions and loss, survival remains one of the most powerful stories ever written among the stars. And as our journey continues, we will discover survivors even stranger than galaxies themselves. Because some objects may persist not for billions of years, but for trillions, surviving long after most of the visible universe has faded into darkness. 7. The worlds hidden around dead suns. The death of a star sounds final, permanent, absolute. When we hear the phrase dead star, it is easy to imagine a cold, lifeless remnant drifting silently through space, its story finished forever. For generations, that was often how we pictured the end of stellar evolution. A star shines, a star ages, a star dies, and everything around it dies too. Simple, clean, complete. But the universe rarely follows the simplest story. Over the past few decades, astronomers have begun uncovering evidence that something remarkable may happen after stars die. Not all worlds vanish with their suns. Not all planetary systems disappear. In fact, some planets may continue orbiting the stellar corpses left behind, entire worlds surviving the destruction of the very stars that once gave them light. Tonight, we explore these hidden survivors, the worlds that circle dead suns, the planets that endured stellar death, and the strange cosmic afterlives that may continue long after a star's brightest days have ended. To understand how such worlds can exist, we first need to understand what happens when stars die. Our own sun is currently middle-aged. It has been shining for roughly 4.6 billion years and still has about 5 billion years of stable life remaining. For now, everything seems calm. Every second, hydrogen deep within the sun's core fuses into helium. Energy flows outward, light reaches Earth, life continues. But this peaceful balance cannot last forever. Eventually, the sun will exhaust the hydrogen fuel in its core. When that happens, it will begin transforming. The star will expand dramatically. Its outer layers will swell outward. The sun will become a red giant. At its largest size, it may stretch far enough to engulf Mercury, possibly Venus, perhaps even Earth itself. For any nearby planets, this phase will be catastrophic. Temperatures will soar, atmospheres will disappear, oceans will evaporate, entire worlds could be consumed. From the perspective of those planets, the end would appear unavoidable. Yet the story does not stop there. After the red giant phase ends, the sun will shed its outer layers into space. What remains behind will be the exposed core, a white dwarf, a stellar corpse. No longer powered by nuclear fusion, no longer generating new energy, simply glowing with residual heat. A white dwarf is astonishingly small compared to the star that created it. Imagine compressing something roughly the mass of the sun into an object about the size of Earth. The result is one of the strangest objects in the cosmos. A teaspoon of white dwarf material would weigh tons. Its gravity would be immense. Its surface temperatures could initially exceed 100,000 degrees Celsius. Yet despite all that, it is technically a dead star. And around some of these dead stars, astronomers have discovered evidence of planets. The first clues appeared unexpectedly. When scientists studied certain white dwarfs, they noticed strange chemical signatures. Heavy elements appeared in their atmospheres. This was puzzling. Gravity inside white dwarfs is so powerful that heavy elements should quickly sink below the surface. They should disappear from view. Yet there they were, again and again. Something had to be replenishing them. Eventually, astronomers realized what might be happening. Asteroids, comets, fragments of destroyed planets. These objects were falling into the white dwarfs, contaminating their atmospheres. In other words, planetary systems were still present. Long after the stars themselves had died, the evidence was impossible to ignore. Around many white dwarfs, remnants of planetary systems continued to exist. Entire cosmic graveyards orbiting stellar corpses. And then came even more astonishing discoveries. Scientists began finding direct evidence of planets themselves, not merely debris, not shattered remnants, actual worlds. One particularly fascinating example involves planets orbiting pulsars. Pulsars are another type of stellar remnant. They form when massive stars explode as supernovae. What remains is an incredibly dense neutron star, a city-sized object containing more mass than the sun. These remnants spin rapidly, sometimes hundreds of times each second. Powerful beams of radiation sweep across space like cosmic lighthouses. Few environments seem less welcoming for planets. And yet, planets exist there. The first confirmed exoplanets ever discovered were actually found orbiting a pulsar. This shocked astronomers. How could planets survive a supernova explosion powerful enough to outshine entire galaxies? The answer remains partly mysterious. Some may have survived. Others may have formed afterward from debris left behind by the explosion. Either possibility is extraordinary. Worlds existing where logic once suggested none should remain. The universe, once again, proving more imaginative than our expectations. But perhaps the most fascinating survivors are planets orbiting white dwarfs. Unlike pulsars, white dwarfs cool gradually. Over billions of years, they become dimmer and dimmer. Eventually, they radiate only faint heat into the surrounding darkness. For a planet orbiting such a star, the sky would be unlike anything we know. Imagine standing on its surface. Above you hangs the exposed core of a dead sun. Small, bright, unnaturally white. A star no larger than a planet. The sunlight would be different. The shadows would be different. The sky itself might feel strangely quiet. You would be living in the afterlife of a solar system, a place where the main story ended long ago. Yet existence continues. Even more intriguingly, some scientists have suggested that habitable conditions could potentially exist around certain white dwarfs. Not immediately after the star's death, the temperatures would initially be far too extreme. But as the white dwarf cools, there may be periods during which planets at specific distances receive suitable amounts of energy. Liquid water might exist, temperatures might stabilize. Life, at least in theory, could persist. Imagine that, life surviving the death of its sun. Or perhaps emerging afterward, entire ecosystems illuminated by the fading embers of a stellar corpse. These possibilities remain speculative. We have not yet discovered such inhabited worlds, but the fact that the idea can be discussed scientifically at all is remarkable. Because only a generation ago, many scientists assumed stellar death meant the end of everything nearby. Now we know the universe is more resilient. Planets survive, asteroids survive, moons survive. Entire systems can persist through catastrophes that once seemed unsurvivable. And perhaps that is one of the most beautiful lessons hidden among these distant worlds. The end of one chapter is not always the end of the story. Stars die, galaxies change, worlds freeze, oceans disappear. Yet sometimes something remains, something continues, something adapts. The planets hidden around dead suns are reminders of that persistence, silent survivors orbiting the remnants of ancient stars, witnesses to events so immense that entire civilizations could scarcely comprehend them. They circle through darkness, year after year, billion after billion years, guarding memories of suns that once blazed brilliantly across their skies. And somewhere among those distant survivors may exist worlds unlike anything we have ever imagined. Worlds illuminated not by youthful stars, but by ancient stellar ghosts. Worlds carrying on long after their suns have faded. And as our journey through these cosmic survivors continues, we will discover that stars and planets are not the only things capable of enduring unimaginable spans of time. Because next, we will encounter some of the most ancient travelers in existence, objects that have been crossing the universe since near the dawn of cosmic history itself. If these peaceful cosmic mysteries help you drift into sleep, save this video so you can return whenever you need another quiet voyage through space. 8. The black holes that will outlive everything. Millions of years from now, the night sky will still be filled with stars. Billions of years from now, galaxies will still shine. Even trillions of years from now, countless red dwarf stars, the longest-lived suns in the universe, will continue burning quietly across the darkness. To any civilization living during those distant eras, the cosmos might still appear eternal, stable, endless, alive. But if we continue traveling far enough into the future, beyond every familiar timescale, beyond the lifetimes of galaxies, beyond the final generations of stars, we arrive at a chapter of cosmic history almost impossible to imagine. A future in which the stars are gone. Not hidden, not obscured. Gone. One by one, the great stellar lights of the universe will eventually fade. And when that happens, something else may become the dominant inhabitants of reality. Black holes. The objects we often think of as destroyers may ultimately become the last major survivors of the stellar age. Tonight we journey into that unimaginably distant future, to a time when nearly everything familiar has disappeared, and when black holes may stand among the final giants still remaining in existence. To understand why, we must first appreciate just how long black holes can survive. Most things in the universe are temporary. Stars exhaust their fuel, planets cool, galaxies collide. Even entire cosmic structures slowly evolve over time. Black holes seem different. At first glance, they appear almost immortal. Once formed, they possess no internal fuel supply that can run out. They do not shine because of fusion. They do not depend on chemical reactions. They simply exist. Mass compressed into a region of space so dense that gravity traps even light itself. For many years, scientists believed black holes might survive forever, an eternal endpoint of cosmic evolution, a final destination from which nothing could escape. But then, in the 1970s, physicist Stephen Hawking revealed something astonishing. Black holes are not completely black. Quantum mechanics suggests they slowly emit tiny amounts of radiation. Today, we call this Hawking radiation. The process is extraordinarily weak. For black holes formed from collapsed stars, the effect is essentially undetectable. A stellar mass black hole absorbs vastly more energy from its surroundings than it loses through Hawking radiation. But over sufficiently long periods of time, the situation changes. Eventually, stars disappear, gas clouds vanish, galaxies grow dark, and once the universe becomes quiet enough, Hawking radiation slowly begins winning the battle. The black hole starts losing mass, very slowly, unimaginably slowly. A black hole with the mass of our sun would require roughly 10 to the power of 67 years to evaporate completely. That number is difficult to comprehend. The current age of the universe is about 13.8 billion years. 10 to the power of 67 years is so vastly larger that the difference makes the age of the universe seem almost insignificant by comparison. Yet even that is small compared to the largest black holes. At the centers of galaxies reside supermassive black holes containing millions or billions of times the mass of the sun. These giants will survive far longer. Some may endure for approximately 10 to the power of 100 years before finally evaporating. A Google years. A number so enormous that writing it requires a 1 followed by 100 zeros. By comparison, every chapter of known cosmic history occupies only the tiniest fraction of that future. And this means something remarkable. Black holes may outlive stars by incomprehensible margins. Imagine the timeline. The last ordinary stars die. Darkness spreads across the cosmos. White dwarfs cool into black dwarfs. Neutron stars slowly fade. Planetary remnants drift through frozen space. Galaxies gradually lose their structure. Yet the black holes remain, silent, patient, unchanged. While entire eras of cosmic history come and go around them, astronomers sometimes refer to this distant epoch as the black hole era. It follows the stelliferous era, the age of stars. In many ways, it represents a completely different universe. A universe where light is rare. A universe where warmth is almost non-existent. A universe whose dominant objects are no longer stars, but gravitational shadows. If a conscious observer somehow existed during this era, the night sky would be unlike anything we can imagine. There would be no bright constellations, no glowing Milky Way, no colorful nebulae. The familiar beauty of the cosmos would be gone. Most black holes themselves would be invisible. Only their gravitational influence would reveal their presence. The universe would become a place defined by darkness. And yet, paradoxically, some of the final light in existence may come from the black holes themselves. As Hawking radiation slowly removes mass, evaporation accelerates. A shrinking black hole radiates more intensely than a larger one. For almost all of its life, this process is imperceptibly slow, but near the end, the pace changes dramatically. The final moments of a black hole's existence could be surprisingly energetic. After surviving for unimaginable stretches of time, the black hole releases its remaining energy in a brief burst. One final flash, one last whisper of light. Then it disappears forever. Imagine witnessing such an event. Not the explosion itself, but the significance behind it. You would be watching an object that survived longer than stars, planets, galaxies, and perhaps nearly every other structure in the universe. An object that endured through eras so vast that entire cosmic civilizations could rise and vanish countless times. And then, after all that time, it simply ceases to exist. A giant finally surrendering to time. One of the strangest aspects of this future is how lonely black holes may become. Today, galaxies are crowded places. Stars orbit one another, planets circle stars. Clusters contain thousands of galaxies. Everything is connected. But over trillions upon trillions of years, gravitational interactions slowly scatter objects into intergalactic space. Many stellar remnants will be ejected from their galaxies entirely. Galactic structures themselves may gradually dissolve. Black holes could spend unimaginable periods isolated from one another, separated by distances so vast that even light would require billions of years to cross them, each becoming its own lonely kingdom of gravity, drifting through eternal darkness. Yet even then, some encounters will still occur. Over enough time, black holes may occasionally merge, two ancient giants spiraling together, combining into something larger, something even longer-lived. These mergers may represent some of the last dramatic events in the cosmos. Long after stars are gone, long after planets have frozen, gravity continuing its quiet work, reshaping the final architecture of existence. And perhaps that is what makes black holes such fascinating cosmic survivors. They are often portrayed as endings, as destroyers, as cosmic monsters that consume everything nearby. But in the far future, they become something else. Not merely endings, but remnants, witnesses, the final custodians of a universe that has forgotten most of its own history. Every black hole contains within its existence a connection to something older, a dead star, a collapsed galaxy, an ancient merger, a forgotten epoch. They are monuments built from the remains of earlier cosmic ages, and for vast stretches of future time, they may be among the last major structures left standing. But even black holes are not eternal. Eventually, Hawking radiation wins. Eventually, every giant fades. Eventually, even gravity's greatest monuments disappear. And when the final black holes evaporate, the universe enters an even stranger chapter. A reality where almost nothing remains except thin fields of energy drifting through endless darkness. A universe so old that the very concept of stars feels like ancient mythology. Yet before we reach that ultimate future, there are still many cosmic survivors left to discover. Because not all remnants of the early universe are black holes. Some are far older than galaxies themselves, ancient travelers that have been crossing space since the dawn of cosmic history, carrying messages from a universe that looked nothing like the one we know today. 9. The last sources of warmth. There is something strangely comforting about warmth. On a cold night, it can come from a blanket, a fireplace, a cup of tea held gently between your hands. Heat is so common in our everyday lives that we rarely stop to think about it. The Earth itself is warm. The sun constantly bathes our world in energy. Even the empty air around us contains countless moving molecules carrying heat from place to place. Warmth feels normal, expected, permanent. But the universe was never designed to remain warm forever. As we continue our journey into the unimaginably distant future, beyond the era of galaxies and beyond the reign of stars, we arrive at a reality where heat becomes extraordinarily rare. A future where warmth itself may become one of the most valuable resources in existence, and where tiny islands of energy could stand out like precious treasures in an ocean of cosmic cold. To understand why, we must first understand a simple truth. The universe is gradually cooling. Not because something is actively removing heat, but because energy is spreading out. Ever since the moment of the Big Bang, the cosmos has been expanding. Galaxies drift apart. Space itself grows larger. And as the universe expands, energy becomes increasingly diluted. The young universe was unimaginably hot. Temperatures were so extreme that atoms could not even exist. Matter existed as a glowing sea of particles and radiation. But with each passing billion years, expansion reduced the average temperature. Today, the universe is already much colder than it once was. Most of intergalactic space sits only a few degrees above absolute zero, and the cooling continues, slowly, relentlessly, for trillions upon trillions of years. At first, stars help resist this trend. Every star functions as a giant furnace, converting hydrogen into light, pouring enormous amounts of heat into surrounding space. As long as stars exist, warmth remains abundant. But stars are temporary. Even the longest-lived red dwarfs eventually exhaust their fuel. One by one, the furnaces begin shutting down. Entire galaxies slowly grow darker. The great stellar age that has illuminated the cosmos for billions of years finally comes to an end. Imagine standing on a planet orbiting one of the last red dwarf stars. The sky would already look unfamiliar. Most bright stars would be gone. Many neighboring galaxies would have vanished beyond the cosmic horizon. Civilizations, if any still existed, might understand that they are witnessing the final chapters of the age of sunlight. And eventually, even that final star dies. Its light fades. Its warmth disappears. Darkness returns. The universe enters an era where new heat sources become extraordinarily important. Ironically, some of the first survivors may be planets. Not living planets like Earth, but frozen worlds preserving internal heat deep beneath their surfaces. Even today, objects such as Jupiter's moon Europa and Saturn's moon Enceladus may contain vast underground oceans warmed by internal energy. Far below thick layers of ice, liquid water remains, protected from the cold vacuum above. These hidden oceans survive because heat becomes trapped. Radioactive elements slowly release energy. Gravitational forces generate friction. The warmth cannot easily escape. In the distant future, similar environments may become some of the last naturally warm places in the cosmos. Tiny pockets of liquid hidden beneath frozen shells, invisible from the outside, yet still carrying heat through the darkness. Some rogue planets may be even more remarkable. These worlds drift through interstellar space without any star at all. At first glance, they seem hopelessly frozen, but large planets can retain internal heat for immense periods of time. A thick atmosphere could act like an insulating blanket, preventing warmth from escaping. Deep below the surface, temperatures might remain surprisingly comfortable, long after every nearby star has vanished, long after the galaxy itself changes beyond recognition. A lone planet wandering eternal darkness may still carry a warm heart. And perhaps, if life ever adapted to such conditions, entire ecosystems could survive hidden far beneath the ice, never seeing a sunrise, never knowing a star, living entirely on the fading warmth of their planet's interior. But even planetary heat eventually declines. Radioactive materials decay, internal reservoirs cool. The universe keeps moving toward greater cold. So what happens next? Surprisingly, some of the last significant heat sources may come from dead stars. White dwarfs, the remnants left behind by stars like our sun, cool extraordinarily slowly. At first, they shine brightly, then gradually dim. Over trillions of years, they become darker and colder. Yet even as they fade, they continue releasing stored thermal energy. A white dwarf is essentially a gigantic cosmic ember, a stellar fireplace radiating the leftover heat of a long-dead sun. Imagine approaching one of these remnants in the distant future. The surrounding universe would be almost completely dark. No nearby stars, no bright nebulae, no glowing galactic disk. Only the faint reddish warmth of an ancient stellar corpse. To travelers of that era, such an object might appear priceless, a rare source of energy in an increasingly frozen cosmos. Neutron stars provide another possibility. These collapsed remnants contain some of the densest matter in existence. Although small, they begin incredibly hot, millions of degrees. Over vast timescales, they cool, but their thermal energy can persist for astonishing lengths of time. Like white dwarfs, they become fading islands of warmth amid expanding darkness. Yet even these survivors cannot last forever. Eventually, the cooling continues, the embers fade, the fires go out. The universe grows colder still, which brings us to one of the strangest sources of future warmth imaginable: black holes. At first, this sounds absurd. Black holes are often associated with darkness and destruction, not heat, not comfort, not survival. But as we discovered in our previous journey, black holes slowly emit Hawking radiation. For most of their existence, the process is incredibly weak, almost negligible. Yet as black holes lose mass, the radiation becomes stronger. In the unimaginably distant future, when nearly every other energy source has vanished, Hawking radiation may become one of the few remaining forms of heat in existence. Imagine a civilization somehow surviving around a black hole trillions upon trillions of years from now. The black hole would not resemble a furnace. Its energy output would be tiny, but compared to the freezing emptiness surrounding it, Even a faint source of warmth could be precious. A black hole might become the equivalent of a campfire in an endless cosmic winter, one of the last places where useful energy still exists. And eventually, after timescales so vast they defy comprehension, even these final heaters disappear. The black holes evaporate, the radiation fades. The remaining warmth spreads thinner and thinner across space. At this stage, the universe approaches what physicists sometimes call heat death. Not an explosion, not a catastrophe, simply equilibrium. A state where usable energy becomes increasingly scarce. Temperatures everywhere drift toward nearly the same value. Differences disappear. And without differences in temperature, many familiar physical processes become impossible. The universe becomes quiet, still, cold. Yet perhaps there is something strangely beautiful about this future, because even as warmth becomes rare, it never completely loses its significance. Throughout cosmic history, warmth has always been associated with possibility. Stars created it, planets preserved it, life depended upon it. Civilizations built themselves around it. And in the final ages of the universe, the smallest remaining pockets of heat may become the last refuges of activity in an otherwise frozen reality. Tiny sparks resisting darkness. Tiny embers carrying forward the memory of a warmer cosmos. And perhaps that is the most remarkable thing of all. The story of the universe is not only a story of stars, galaxies, and black holes. It is also a story of warmth, of energy flowing through time, of heat gradually fading, but never vanishing all at once. A long, slow transition stretching across unimaginable ages. And as the final sources of warmth grow rarer and rarer, another question begins to emerge. If heat eventually becomes scarce everywhere, what happens to the last places where life might still survive? 10. The rogue planets carrying ancient histories. Some planets are born into warm and crowded neighborhoods. They circle bright stars, watch suns rise and set, experience seasons, sunlight, and the steady gravitational embrace of their parent systems. For billions of years, these worlds remain part of a family. A star at the center, planets moving in predictable paths, moons orbiting planets, everything bound together by gravity. But not every planet is fortunate enough to stay where it began. Across the universe, countless worlds have been violently ejected from their homes, thrown into interstellar darkness, cast out from the systems that created them. And once they leave, they may never return. Tonight, we continue our journey into the hidden universe by following some of the most mysterious travelers in existence, the rogue planets carrying ancient histories, worlds that once knew sunlight, worlds that once belonged somewhere, worlds that now drift endlessly through the darkness between stars. What makes these objects so fascinating is not simply their isolation. It is the possibility that each one may be carrying the preserved memory of a lost cosmic past. A history written billions of years ago. A history that continues traveling through the galaxy long after everything that created it has changed. To understand how this happens, we must first imagine the chaotic nature of young planetary systems. When stars are born, they rarely emerge into perfectly ordered environments. New planets form from enormous disks of gas and dust swirling around infant suns. At first, everything is crowded. Giant planets migrate, asteroids collide, gravitational forces pull worlds in unexpected directions. The process can be surprisingly violent. Computer simulations suggest that many planetary systems experience periods of instability. Massive planets may interact gravitationally with one another. Their orbits shift. Some are pushed inward toward their stars, others move outward, and occasionally a smaller world receives a powerful gravitational kick. A single close encounter can change everything. Instead of continuing its orbit, the planet is accelerated beyond escape velocity. The star's grip weakens, the planet drifts farther away, and eventually it leaves forever. A world that once circled a sun becomes a rogue planet, an orphan of the cosmos. Astronomers now believe rogue planets may be extraordinarily common. Some estimates suggest there could be billions or even trillions of them throughout our galaxy alone. Perhaps more rogue planets than stars. If that idea sounds surprising, consider how many opportunities exist for planets to be ejected. Every unstable planetary system creates potential wanderers. Every stellar encounter can disrupt existing orbits. Every dying star can dramatically alter the balance of gravity around it. Over billions of years, the galaxy becomes filled with these silent travelers. Most are nearly impossible to detect. They emit little or no visible light. They drift through darkness, invisible against the vast black background of space. Yet despite their hidden nature, they may carry astonishing stories. Imagine a rogue planet that formed more than 10 billion years ago. When it was young, the universe itself looked different. The Milky Way was still growing. Many modern stars had not yet formed. Entire galaxies occupied different positions. Ancient clusters glowed brightly across the cosmic landscape. For perhaps hundreds of millions of years, this world orbited peacefully around its star. It may have possessed oceans, atmospheres, moons. Perhaps storms rolled across its skies. Perhaps sunlight illuminated its continents every morning. Then something happened. A gravitational encounter. A passing giant planet. A nearby stellar flyby. The details are lost to history, but the result was permanent. The planet was expelled, and for billions of years afterward, it wandered alone. During that time, entire civilizations on Earth would eventually appear and disappear. Dinosaurs would rise and vanish. Continents would drift. The sun would continue its long journey around the galaxy. Meanwhile, the rogue planet would simply keep moving, quietly preserving a piece of ancient cosmic history. In some ways, these worlds resembled drifting time capsules. Stars evolve, galaxies collide, planetary systems change. But a rogue planet may remain largely unchanged for immense stretches of time, especially if it is geologically inactive. Its surface might preserve ancient impact craters dating back billions of years. Its composition may reveal conditions from a much earlier era of galactic history. Its rocks could contain clues about stars that no longer exist. Imagine landing on such a world. The night sky would be unlike anything experienced on Earth. There would be no nearby sun. No blue daytime sky, no sunrise, no sunset, only the distant glow of stars scattered across eternal darkness. Yet those stars would slowly change over immense periods. Constellations would shift. Neighboring stars would drift. Galaxies would move. The rogue planet would witness all of it, a silent observer traveling through cosmic time. But perhaps the most fascinating possibility involves life. At first glance, a rogue planet appears hopelessly frozen. Without sunlight, surface temperatures plunge, oceans freeze, atmospheres may collapse. The world becomes a frozen sphere drifting through space. Yet as we explored earlier, appearances can be deceiving. Some rogue planets may retain substantial internal heat. Radioactive decay within their interiors continues generating energy. Large planets can trap that warmth for billions of years. If a thick atmosphere remains, it can act as insulation, preventing heat from escaping into space. Beneath the frozen exterior, liquid water may persist. Underground oceans may survive. And wherever liquid water and energy coexist, scientists cannot entirely dismiss the possibility of life. Imagine an ancient rogue planet ejected from its star system 8 billion years ago. On the surface, nothing moves. Everything is frozen. Darkness dominates. But miles below the ice, hidden oceans remain warm. Microbial ecosystems thrive. Evolution continues. Entire biological histories unfold unseen. For billions of years, without ever witnessing a sunrise, without ever seeing a star. Life surviving entirely on the planet's internal heat. It sounds almost like science fiction, yet it is rooted in real scientific possibilities. And if such worlds exist, they may represent some of the longest-lasting habitats in the universe. Long after many stars have died, long after countless planets become uninhabitable, these hidden oceans could continue quietly supporting life. The idea becomes even more fascinating when we think about the future. As stars gradually disappear across trillions of years, rogue planets may become increasingly important, not because they are bright, not because they are easy to find, but because some may preserve warmth longer than expected. Tiny refuges scattered throughout a cooling cosmos, ancient survivors carrying memories of a younger universe. And perhaps that is what makes rogue planets so strangely beautiful. They embody both loss and endurance. They are worlds that lost their homes, worlds that lost their suns, worlds that lost the familiar rhythms of day and night. Yet they survived, still drifting, still existing, still carrying their histories through the darkness. Every rogue planet may be a reminder that survival in the universe often takes unexpected forms, not through power, not through brightness, but through persistence, through continuing onward even after everything familiar has disappeared. And as we follow these wandering worlds farther into the future, another survivor begins to emerge from the darkness, an object even more enduring than rogue planets, an object that may remain long after most stars, planets, and galaxies have faded away, the ultimate survivor of cosmic time, the black holes that may one day outlive almost everything else in existence. 11. The future homes of life. There is a quiet assumption hidden inside almost every story we tell about life in the universe. When we imagine alien civilizations, future descendants of humanity, or life surviving across cosmic time, we almost always picture something familiar: a planet, an atmosphere, an ocean, a sun shining overhead, some version of Earth. After all, every living thing we have ever known evolved on a planetary surface beneath the warmth of a star. It feels natural to assume that the future of life will always depend on worlds like our own. But what if that assumption is wrong? What if the ultimate homes of life are not Earth-like planets at all? What if the places where life survives longest are environments so strange that they barely resemble the worlds where life first began? Tonight, as our journey through the universe continues, we arrive at one of the most fascinating questions in all of cosmic history. If life survives long enough, where will it eventually go? Because the universe is changing, slowly, relentlessly. Stars are aging, galaxies are evolving. The conditions that made Earth possible are not permanent, and over unimaginably long timescales, life may be forced to adapt to entirely new cosmic realities. To understand why, we must first remember something remarkable about life itself. Life is not loyal to any particular place. Life is loyal to survival. Here on Earth, organisms have learned to live inside boiling hydrothermal vents deep beneath the ocean floor. Microbes thrive inside Antarctic ice. Some survive intense radiation. Others endure crushing pressures at the bottom of the sea. Life repeatedly demonstrates an astonishing ability to exploit environments that once seemed impossible. Again and again, biology teaches the same lesson. If a habitat exists, life may eventually find a way to use it. And that possibility becomes especially intriguing when we begin looking beyond traditional planets. Consider the icy moons scattered throughout our solar system. For centuries, they appeared unremarkable: frozen worlds, dead worlds, small companions orbiting giant planets. Yet modern science has revealed something unexpected. Beneath their frozen crusts may exist enormous oceans, hidden seas containing more liquid water than all of Earth's oceans combined. Worlds like Europa, worlds like Enceladus, worlds where sunlight barely matters. Their oceans are not warmed by the sun. Instead, they are heated internally. Gravity itself becomes the energy source. As giant planets tug and stretch their moons, friction generates heat deep within their interiors. Liquid water survives, perhaps for billions of years. These environments force us to reconsider one of our oldest assumptions. Maybe a habitable world does not need sunlight. Maybe life can flourish in darkness. Maybe oceans hidden beneath ice represent a completely different pathway for biology. And if that is true, then the future homes of life may be far more diverse than we once imagined. Now imagine a civilization millions or billions of years more advanced than our own. Such beings would not necessarily remain attached to the surface of a single planet. Planets are fragile. Asteroids strike, stars evolve, climate changes, entire worlds become unstable. A sufficiently advanced civilization might eventually seek habitats that offer greater longevity. Instead of living on planets, they might construct artificial environments, vast, rotating habitats floating through space, gigantic structures designed to provide gravity, temperature control, and protection from radiation. Unlike planets, such habitats could be repaired, expanded, moved, customized. Their survival would not depend on the fate of a particular world. In a sense, life would begin creating its own homes, no longer tied to nature's designs, no longer dependent upon Earth-like environments. The universe would become an ocean of possibilities. And yet even these artificial habitats may eventually face challenges, because the stars themselves are temporary. The Sun has roughly 5 billion years remaining. Other stars will live longer, some far longer. Red dwarf stars, for example, burn their fuel so slowly that they may survive for trillions of years. Trillions, not billions, trillions. These tiny stars are among the most remarkable objects in the cosmos. They shine dimly, patiently, efficiently. Long after larger stars have vanished, red dwarfs may continue illuminating their planets. In fact, if life seeks long-term stability, worlds orbiting red dwarfs may become some of the most valuable real estate in the universe. Future civilizations might migrate toward these stellar survivors, leaving younger, shorter-lived stars behind, following longevity itself, seeking refuge around the stars that refuse to die. Yet even red dwarfs are not eternal. Eventually, every star exhausts its fuel. Every stellar system changes. And this raises an even stranger possibility. Perhaps life's ultimate future lies around dead stars. At first, that sounds absurd. A dead star seems like the last place life would choose to live. But remember the hidden oceans we explored earlier. A white dwarf may continue radiating heat for billions of years after its stellar death. Planets orbiting nearby could potentially maintain habitable conditions. Some researchers have even suggested that habitable zones may briefly exist around cooling white dwarfs, worlds illuminated not by youthful stars, but by stellar remnants. Imagine civilizations living beneath skies dominated by glowing white dwarfs, the remnants of ancient suns. Survivors inhabiting systems that have already witnessed stellar death. Such environments would have seemed impossible to earlier generations, yet the laws of physics do not forbid them. And as cosmic time stretches onward, even stranger habitats begin to emerge. Far in the future, rogue planets may become important refuges. These lonely wanderers possess certain advantages. They are isolated, protected from stellar explosions, protected from many of the dangers associated with crowded star systems. If they retain internal heat, hidden oceans may survive for extraordinary lengths of time. Life beneath thick ice could continue long after surface civilizations elsewhere have vanished. The darkness would be complete, yet life may endure, invisible, patient, waiting. And then we arrive at perhaps the strangest possibility of all: black holes. For most of human history, black holes have been portrayed as destroyers, cosmic predators, the ultimate symbols of death and emptiness. Yet some physicists have explored fascinating scenarios involving energy extraction from black holes. Under the right conditions, rotating black holes contain enormous amounts of usable energy. Future civilizations, if they ever become advanced enough, might learn to harness this energy, not merely surviving near black holes, but thriving around them. Imagine habitats orbiting safely outside a black hole's event horizon, powered by processes we can barely comprehend today. Artificial worlds illuminated by engineered energy systems. Civilizations enduring long after normal stars have disappeared. It sounds extraordinary, yet cosmic history repeatedly teaches us caution whenever we declare something impossible. Again and again, nature proves more creative than our expectations. Perhaps the most important lesson is that life's future may become increasingly detached from the environments where life first originated. Just as humanity no longer lives exclusively in caves, future life may no longer depend exclusively on planets. Evolution adapts. Technology expands possibilities. Survival encourages innovation. The homes of tomorrow may look nothing like the homes of yesterday. And if life persists across trillions of years, its descendants may inhabit environments that would seem almost magical to us now. Hidden oceans, artificial worlds, dead star systems, rogue planets. Perhaps even structures orbiting black holes. Each possibility represents a different answer to the same ancient challenge. How do you survive in a changing universe? Because survival has never been about remaining where you started. It has always been about adapting to what comes next. And as our journey continues, we will soon encounter another group of cosmic survivors, objects that may preserve memories from the earliest eras of creation itself. Ancient relics carrying stories from a universe far younger than the one we know today, the oldest survivors of cosmic history. 12. The survivors of cosmic winter. For most of human history, winter has been a familiar concept. A season, a temporary period of cold, a time when life slows down, waits patiently, and endures until warmth returns. Spring always follows. The sun always rises again. The cold never lasts forever. But the universe follows different rules. There is a winter approaching that has no spring, a slow and silent cooling that unfolds across timescales so vast they almost defy imagination. Not thousands of years, not millions, not even billions, trillions upon trillions of years. A future when the great age of stars gradually comes to an end. A future when darkness begins to dominate more and more of existence. And yet, even during this immense cosmic winter, a handful of remarkable survivors may continue resisting the cold. Tiny islands of energy, ancient relics of brighter eras. Objects so durable that they may outlive nearly everything else in the universe. Tonight, we follow those survivors into the deepest future. Because while most of the cosmos will eventually grow quiet, not everything will surrender to the darkness at the same time. The story begins with the stars. At this very moment, stars are being born throughout the universe. Clouds of gas collapse. Gravity pulls matter together. Nuclear fusion ignites. New suns begin shining. The stellar age continues. But it cannot continue forever. Every star requires fuel. Hydrogen is abundant, but not infinite. Over unimaginable spans of time, galaxies slowly consume their supplies. Star formation gradually declines. The universe becomes less productive, less luminous, less alive with new beginnings. Astronomers sometimes refer to our current era as the stelliferous era, the age of stars, a remarkably fortunate period in cosmic history. We exist during the brief window when countless suns illuminate countless galaxies, but this era is temporary. Far in the future, star formation will largely cease. The cosmic factories that once produced new stars will shut down. The universe will enter a quieter chapter. And yet, even as most stars disappear, some extraordinary survivors remain. Among the greatest of these survivors are red dwarf stars. We have encountered them before during our journey. Small, dim, easy to overlook. Yet they possess a secret that makes them among the most important objects in the future universe. They are astonishingly efficient. A star like our sun burns through its hydrogen relatively quickly. In cosmic terms, its life expectancy is only about 10 billion years. A red dwarf behaves very differently. Its lower mass allows it to consume fuel with incredible patience. Some red dwarfs may continue shining for trillions of years. Trillions. That number is so large that it exceeds the current age of the universe by hundreds of times. Long after stars like the sun have died, red dwarfs will still glow softly in the darkness. If life survives far enough into the future, these stars may become precious sanctuaries. Tiny beacons of warmth scattered throughout an increasingly cold cosmos. Entire civilizations might one day gather around them, not because they are spectacular, but because they endure. In a universe where longevity becomes the most valuable resource, endurance itself becomes a form of wealth. Yet even red dwarfs eventually reach their limits. Nothing powered by fusion lasts forever. One by one, these stellar survivors will fade, and when they do, another generation of cosmic survivors emerges. White dwarfs. The dense remnants left behind after stars exhaust their fuel. A white dwarf is not truly alive in the stellar sense. Fusion has ended. Its brilliant youth is over. Yet it does not vanish. Instead, it begins an extraordinarily slow cooling process. Imagine a cosmic ember, a glowing coal left after a fire has gone out. The flame is gone, but heat remains. For billions, trillions, even quadrillions of years. White dwarfs may continue radiating stored energy long after active stars disappear. In the future universe, these ancient remnants could become some of the last significant sources of warmth. Their light would be faint, their glow subtle. But against the backdrop of growing darkness, even a faint ember becomes precious. And some white dwarfs may survive for lengths of time that almost seem impossible. So long, in fact, that the universe has not yet existed long enough for a single one to fully cool. Not one. Every white dwarf ever formed is still retaining heat today. The universe itself is simply too young. But eventually, after unimaginable stretches of time, even these embers cool. They become hypothetical objects known as black dwarfs, cold stellar corpses, invisible remnants drifting through eternal night. No black dwarf exists yet. The cosmos has not lived long enough to create one. Yet they represent another stage in the story of survival, a reminder that even death in the universe often unfolds slowly, almost gently. As cosmic winter deepens further, another class of survivors begins to dominate. Brown dwarfs, sometimes called failed stars. These objects never became massive enough to sustain normal stellar fusion. For billions of years, they have lingered between categories, neither star nor planet, quietly cooling, quietly enduring. In the far future, brown dwarfs may become some of the most common luminous objects remaining. Their glow is weak, mostly infrared, invisible to human eyes. Yet they continue radiating energy long after brighter stars disappear. A future traveler crossing the cosmos might find brown dwarfs scattered like faint lanterns throughout an otherwise dark universe. Not powerful enough to command attention, but resilient enough to outlast giants. And then there are the ultimate survivors, black holes. No discussion of cosmic winter would be complete without them. Throughout our journey, black holes have repeatedly appeared as symbols of endurance. That reputation is well earned. When stars die, some collapse into black holes. Galaxies merge, producing even larger ones. Over time, black holes accumulate mass, grow, persist, while stars fade around them. In many ways, black holes inherit the universe. They become the dominant remnants of the stellar age. And their lifespans are astonishing. A supermassive black hole may survive for timescales measured not in trillions of years, but in numbers so enormous that ordinary language begins to fail. A Google years, far beyond anything resembling human experience. Far beyond civilizations, far beyond galaxies. Yet even black holes are not eternal. One of the most extraordinary discoveries in modern physics came from the work of Stephen Hawking. Black holes slowly evaporate. Not quickly, not dramatically, but gradually, particle by particle. Energy leaking away through a process now known as Hawking radiation. For unimaginably long periods, the effect is negligible. Then, near the end, evaporation accelerates. Eventually, even the greatest black hole disappears, its existence ending in a final release of energy. For much of cosmic winter, black holes may be among the last active objects remaining, but even they cannot resist forever. And this realization reveals something profound. The survivors of cosmic winter are not immortal. They simply endure longer, much longer. Each generation of cosmic survivors inherits the universe from the previous one. Red dwarfs outlive ordinary stars. White dwarfs outlive red dwarfs. Black holes outlive white dwarfs. The darkness advances slowly, step by step, epoch by epoch. Yet every stage leaves behind something that continues the story a little longer, a little farther, a little deeper into time. And perhaps that is what makes these survivors so fascinating. They remind us that endings in the universe rarely happen all at once. Instead, they unfold gradually, like a fading melody, like the last glowing coals in a dying fire, like winter settling across an endless landscape, one quiet moment at a time. Before we continue deeper into the far future, there is something I would like to ask. If these distant futures fill you with wonder, share this journey with someone who enjoys falling asleep while imagining the farthest reaches of time. And now, as the universe grows colder around us, we move toward another mystery, a question that becomes increasingly important as warmth becomes scarce. In a future where almost everything freezes and fades away, where will the last remaining sources of energy be found? 13. The last galaxies to shine. There is a strange assumption hidden inside almost every picture we have ever imagined of the future universe, that one day the lights simply go out, that galaxies fade, stars die, darkness wins. And while there is truth in that vision, the reality may be far more gradual and far more fascinating. Because even as the universe slowly ages, not all galaxies will fade at the same rate. Some will exhaust their fuel early. Some will be torn apart by collisions. Some will lose the gas needed to create new stars. Yet a select few may continue shining long after most of the cosmos has entered darkness, far beyond our own era, far beyond the age of the Milky Way as we know it, far beyond the lives of every star currently visible in Earth's night sky. There may come a time when only a handful of galaxies still possess the ability to create new suns, tiny islands of creation floating within an ocean of cosmic night. Tonight, we travel toward those final galaxies, the last great stellar cities of the universe, the final places where new starlight is born. To understand why these galaxies are so special, we first need to understand what allows galaxies to shine in the first place. A galaxy is not simply a collection of stars. It is also a reservoir, a vast storehouse of gas, hydrogen drifting between stars, clouds waiting patiently for gravity to gather them together. Every new star begins inside one of these clouds. Gravity slowly compresses the gas. The cloud becomes denser, hotter. Eventually, nuclear fusion ignites. A star is born. This process has repeated itself for billions of years, again and again, across countless galaxies. But every new star consumes part of the available supply. The reservoir slowly shrinks, like water being drawn from an ancient well. And eventually, if no new gas arrives, the well runs dry. Many galaxies are already approaching this fate. Astronomers call them red and dead galaxies. The name sounds dramatic, but it reflects a simple reality. Their brightest, youngest stars have vanished. No significant star formation remains. Only older stars continue shining. These galaxies are not truly dead, but their most creative era has ended. Their stellar future has largely been written, and over the coming billions of years, more galaxies will join them. The universe is gradually becoming less productive, less fertile, less capable of creating entirely new generations of stars. Yet not every galaxy follows the same path. Some are surprisingly efficient at preserving their fuel. Others continue gathering fresh material from their surroundings. A few may possess enough resources to keep star formation alive for astonishing lengths of time. These future survivors are likely to be small galaxies, not giant spiral galaxies like our own, not enormous elliptical galaxies filled with ancient stars. Instead, many may be humble dwarf galaxies, the cosmic equivalent of quiet villages surviving long after great empires have disappeared. This may seem surprising. After all, larger galaxies contain more stars, more gas, more matter. Shouldn't they survive longer? Not necessarily. Large galaxies often burn through their resources more quickly. Their massive stellar populations generate intense radiation. Supernova explosions stir the surrounding gas. Black holes and galactic centers can heat enormous regions of space. All of these processes can disrupt future star formation. Sometimes the largest systems consume themselves fastest. Smaller galaxies often live more carefully. Their pace is slower, their fuel consumption gentler. And in the distant future, patience may prove to be the greatest survival strategy of all. Imagine a dwarf galaxy trillions of years from now. Most of the universe has already changed beyond recognition. The great stellar age is fading. Bright blue stars are gone. Massive stars exist only in memory. Many neighboring galaxies have become dark collections of ancient stellar remnants. Yet within this tiny galaxy, pockets of hydrogen still remain. Gravity continues its quiet work. New red dwarf stars continue forming. Not many, not rapidly, but enough. Enough to keep the lights on. Enough to maintain a small corner of creation while the wider universe grows colder. For any future observers living there, the galaxy might seem extraordinarily precious, a sanctuary, a refuge, a final reminder of what the universe once looked like everywhere. Because by that point, active star formation itself may become a rare luxury, a phenomenon almost worthy of reverence. And perhaps the most remarkable aspect of these final shining galaxies is not their brightness, it is their longevity. The stars they create near the end of the stellar era are unlikely to be massive. Massive stars live fast and die young. They consume fuel recklessly. They explode after only millions of years. The future universe favors a different kind of star. Small stars, cool stars, patient stars. Red dwarfs. The same stellar survivors we encountered earlier in our journey, these tiny suns can burn for trillions of years. Each new red dwarf born inside a future galaxy becomes another long-lived beacon, another candle capable of shining across almost incomprehensible stretches of time. A galaxy producing even a few such stars may extend its visible life enormously, long after more dramatic galaxies have faded away. Long after the cosmic headlines belong to black holes and stellar remnants. These quiet galaxies may continue writing new chapters, and yet even they cannot continue forever. The laws of physics remain patient, but they are relentless. Eventually, every galaxy faces the same challenge. The supply of raw material dwindles. Hydrogen becomes scarce. The clouds grow thinner, star formation slows further, then slows again and again, until eventually the process nearly stops altogether. The final stars emerge, the last births occur. The great stellar factories close their doors, one by one, galaxy by galaxy. The universe enters an era unlike anything we can easily imagine, an era where new stars become extraordinarily rare. Not impossible, just rare enough to feel miraculous. If a future civilization somehow witnessed the formation of a new star during this age, it might be regarded as an event of profound significance. The birth of a star could become something worthy of generations of observation, a reminder that creation still exists, even if only barely, even if only for a little longer. And perhaps this is what makes the final galaxies so beautiful. Not their size, not their power, not their brightness, but their persistence. They continue creating while almost everything else is winding down. They continue building while the universe slowly dismantles itself. They continue shining while darkness advances from every direction. In a sense, they become symbols of resistance. Not resistance against an enemy, but resistance against inevitability itself. Tiny pockets of activity refusing to disappear. Small communities of stars carrying the memory of a younger cosmos. And eventually, even those memories begin to fade. The final galaxies exhaust their fuel. The final red dwarfs inherit the future. The age of active star formation comes to an end. For the first time since the earliest generations of stars appeared after the cosmic dark ages, no truly new stellar civilizations emerge. No fresh suns ignite, no new dawns arrive. Only the long, patient glow of stars already born. Yet even then, the universe is not completely dark, because many of those final stars will continue shining for trillions upon trillions of years. The last galaxies may stop creating light, but the light they already created will endure for ages beyond imagination. And as we drift onward into the deep future, another question begins to emerge. If the final galaxies eventually stop producing stars, what happens to the civilizations, worlds, and possible forms of life that once depended on them? Where might they go when even the last stellar cities begin to fade? That mystery awaits us in the next stage of our journey through the far future of the cosmos. 14. The final islands of light. Far in the future, isolated regions of the cosmos may become the last places where starlight still exists. At first, that idea sounds impossible. After all, the universe contains hundreds of billions of galaxies. Each galaxy contains billions or even trillions of stars. The night sky appears overflowing with light. How could all of that ever shrink into a few isolated pockets? How could something so vast become so lonely? Yet the deeper astronomers study the future of the cosmos, the more they realize that loneliness may be one of the defining features of the universe's destiny. Not because stars suddenly disappear, not because galaxies instantly fade, but because space itself never stops growing. Even now, as you listen tonight, the universe is expanding. Galaxies are drifting farther apart. The distances between the great cosmic structures increase every second. And unlike many things in nature, this process does not slow down. In fact, it accelerates. The mysterious force we call dark energy appears to be pushing the expansion faster and faster as time passes. For billions of years, this effect remains subtle. Galaxies still fill the heavens. The universe remains rich with visible structure. But over unimaginable stretches of time, the consequences become extraordinary. Galaxies beyond our local cosmic neighborhood begin disappearing, not because they are destroyed, not because they stop existing, but because they move so far away that their light can never reach us. One by one, distant galaxies slip beyond the observable horizon. The universe gradually hides itself. Imagine standing on a shoreline while islands slowly sink beneath the horizon. The islands still exist, but they become unreachable, invisible, lost beyond sight. The future cosmos may experience something remarkably similar. Eventually, observers living trillions of years from now may see only a tiny fraction of the galaxies visible today. The vast cosmic web that currently stretches across billions of light years will become increasingly difficult to detect. Most of it will simply vanish from view. This creates one of the strangest ironies in cosmic history. The future universe may actually contain less visible information than the universe we inhabit now. Future astronomers could know less about the cosmos than we do. Not because they are less intelligent, not because their technology is weaker, but because much of the evidence will have disappeared beyond reach. The universe itself slowly erases its own history. And as this process continues, only a few gravitationally bound regions remain intact. These become the final islands of light, enormous structures where gravity is strong enough to resist the expansion of space. Collections of galaxies locked together by their mutual attraction, safe from complete separation, protected from drifting away forever. One of these future islands will likely be the merged descendant of our own galaxy. Today, the Milky Way and the Andromeda Galaxy are slowly moving toward each other. In roughly 4 to 5 billion years, they are expected to collide. Not in a catastrophic explosion, not in the dramatic way Hollywood often imagines. The stars themselves are so far apart that direct collisions remain unlikely. Instead, the galaxies will gradually pass through one another. Their shapes will distort, their gravitational fields will intertwine. Over time, they will merge into a single enormous galaxy. Astronomers sometimes call this future structure Milkomeda, a strange name, yet it may represent the future home of countless stars that survive into later cosmic eras. For trillions of years afterward, this giant galaxy could remain one of the universe's final visible kingdoms, a luminous oasis surrounded by expanding darkness. And it may not be alone. Other galaxy groups throughout the cosmos will experience similar fates. Clusters and superclusters will slowly condense into isolated stellar realms, each becoming its own self-contained universe, its own final island of light. Imagine standing on a world orbiting a star in one of those future galaxies. The night sky would look profoundly different from ours. Today, when we gaze upward, we see evidence of a crowded universe. Billions of galaxies fill the darkness. Ancient light arrives from every direction. The cosmos feels enormous, connected, alive. But trillions of years from now, much of that grandeur may be gone. The sky could appear surprisingly empty. Perhaps only the stars of the local galaxy remain visible. Everything beyond it has disappeared beyond the cosmic horizon. Future civilizations might never know that countless other galaxies once existed. The evidence would be inaccessible. The universe would seem smaller than it truly is, a cosmic illusion created by time itself. Yet within those isolated galaxies, life may continue. Stars still shine, planets still orbit. Civilizations, if any survive, may still wonder about existence. In some ways, these future islands become sanctuaries, places where complexity continues while the larger universe grows increasingly cold and sparse. The stars inside them may become precious beyond measure, because outside these islands, darkness steadily expands, and the darkness itself changes. The universe grows older, star formation slows. The great stellar factories gradually shut down, hydrogen becomes harder to find, new suns become increasingly rare. The islands remain bright, but they are no longer producing light as easily as before. They are living on accumulated wealth, spending reserves gathered across trillions of years, like ancient cities surviving on resources stored long ago. Eventually, many of the brightest stars vanish. Only smaller stars remain. Red dwarfs become dominant, patient survivors capable of shining for trillions of years. Their gentle red light illuminates the final islands, not with brilliance, but with endurance. This is a recurring theme throughout the future cosmos. The universe increasingly favors patience over power. Massive stars die early, tiny stars survive. Large galaxies exhaust their fuel. Careful systems endure. The future belongs to those that consume slowly. And so the final islands of light may not be dazzling. They may not resemble the spectacular galaxies seen in modern astronomical photographs. Instead, they may glow softly, quietly, a handful of ancient stars scattered through enormous darkness. Yet perhaps that makes them even more beautiful, because beauty is not always found in abundance. Sometimes beauty emerges through rarity. A single candle becomes more meaningful in darkness than beneath a bright afternoon sun. Likewise, the final stars may feel more precious than all the brilliant galaxies of earlier ages, not because they are brighter, but because so few remain. And eventually, even these islands begin changing. The stars continue aging, white dwarfs accumulate, neutron stars drift through the galaxy, black holes slowly gather matter. The structure remains, but its population evolves. The stellar age approaches its conclusion. The islands continue glowing, but the nature of that glow transforms. The universe is quietly preparing for an even stranger chapter. A chapter where starlight itself is no longer the dominant source of illumination, where black holes become some of the most important objects left, where the remnants of ancient stars inherit the cosmos. And as the final islands drift through the darkness, carrying the last surviving stellar communities with them, another question begins to emerge. What happens when even these islands begin losing their stars? When the final lights themselves start fading? When the universe reaches a point where almost every remaining source of warmth and illumination comes not from living stars, but from the relics they leave behind? That journey takes us deeper still into the far future, toward the age when the last traces of the stellar universe finally begin surrendering to time. 15. What will remain after trillions of years? Imagine looking out across a universe where nearly every familiar object has disappeared. No bright spiral galaxies stretching across the heavens. No clusters of young blue stars. No glowing nebulae painting the darkness with color. No crowded cosmic landscape filled with endless possibilities. Just silence, darkness, and a handful of survivors scattered across distances so vast that even light struggles to bridge them. At first, such a universe sounds empty, almost lifeless, a place stripped of everything that makes the cosmos beautiful. But the truth may be far stranger, because even after trillions upon trillions of years have passed, the universe will not be completely gone. Its story will not be over. Instead, it will enter a chapter unlike anything we can observe today, a universe composed almost entirely of survivors, the remnants of an age long forgotten. And perhaps the most remarkable thing about that future is how little it resembles the cosmos we know now. Tonight, stars dominate the universe. Nearly everything we associate with astronomy revolves around them. Stars create light. Stars create planets. Stars forge heavy elements. stars shape galaxies. Stars provide the energy that allows life to exist. In many ways, the current era could be called the age of stars. Yet this age occupies only a tiny fraction of cosmic history, a brief, bright chapter within a far longer story. Eventually, the stars begin disappearing. Not all at once, not through some cosmic catastrophe, but through the slow and patient passage of time. The largest stars vanish first. They always do. These brilliant giants burn through their fuel rapidly. Some survive only a few million years. Their lives are spectacular but short. The universe loses them early. Smaller stars endure longer, much longer, especially red dwarfs. These tiny stars sip their fuel so slowly that many can survive for trillions of years, long after our sun has died, long after entire galaxies stop forming new stars, long after civilizations we cannot yet imagine have come and gone. Yet even red dwarfs are not immortal. Eventually, they too exhaust their fuel. The last true stars slowly disappear from the cosmos, and when that happens, the universe begins to change in a profound way. For the first time since the earliest galaxies formed, starlight no longer dominates reality. The sky enters a new age, an age of remnants. Imagine drifting through space during this distant era. What would you actually see? The answer begins with white dwarfs. These stellar remnants are the exposed cores left behind when sun-like stars die, roughly the size of Earth, packed with incredible density, glowing from leftover heat. White dwarfs are not powered by active fusion. They simply radiate stored energy into space, slowly cooling over unimaginable periods of time. At first they shine brightly, then gradually dim, eventually becoming something astronomers call black dwarfs, cold stellar corpses, invisible against the darkness. The universe of the far future may contain countless black dwarfs, ancient relics of stars that once illuminated entire planetary systems, ghosts of forgotten suns. Alongside them drift neutron stars, objects so dense that a teaspoon of their material would outweigh mountains, the remnants of massive stellar explosions. Some continue spinning for billions of years, their magnetic fields slowly weakening, their energy fading. Yet they remain among the most extraordinary objects ever created, ancient monuments to a more violent cosmic past. And then there are black holes, the ultimate survivors. Throughout our journey, we have encountered black holes again and again, and for good reason. As the stellar age fades, black holes inherit an increasingly important role. Many stars ultimately become black holes. Galaxies contain supermassive black holes at their centers. Over trillions of years, countless mergers occur. Black holes grow, combine, accumulate mass. While stars vanish, black holes remain, patient, silent, persistent. In a universe where nearly everything else is fading, black holes become some of the most durable structures in existence. Imagine looking across a future galaxy. The brilliant spiral arms are gone. The young stars have disappeared. The nebulae have faded. What remains is a population of stellar remnants orbiting through darkness. White dwarfs, black dwarfs, neutron stars, black holes. A cosmic graveyard stretching across space. And yet, surprisingly, motion never completely stops. Gravity continues its work, even after unimaginable spans of time. Objects occasionally pass near one another. Orbits shift. Stars' remnants exchange energy. Some are ejected from galaxies entirely. Others fall inward toward central black holes. The universe becomes quieter, but never perfectly still. There is another survivor too, one that rarely receives attention: planets. Worlds may persist far longer than many people realize, even after their stars die, even after galaxies stop forming new suns. Planets can continue orbiting stellar remnants, frozen, dark, silent, but still existing. Ancient worlds carrying memories of vanished stellar systems. Some may wander alone through interstellar darkness. Rogue planets adrift for trillions of years, tiny islands of matter preserving histories that no observer remains to remember. In many ways, these worlds become time capsules, physical evidence that stars once shone, that oceans once existed, that complexity once flourished. And perhaps somewhere among these remnants, traces of life may survive longer than we expect. This enters the realm of speculation, yet it is difficult to ignore. Life is remarkably resilient. On Earth, it thrives in deserts, deep oceans, frozen ice, volcanic vents, environments once thought impossible. Could future life adapt to the remnants of dying stars? Could civilizations find ways to harvest energy from black holes? Could intelligence migrate between stellar corpses as the universe evolves? We do not know, but the question itself reveals something important. The far future universe is not necessarily empty. It is simply different. The rules change, the opportunities change, the sources of energy change. Existence becomes harder, but not immediately impossible. And perhaps that is the deepest lesson hidden within the future cosmos. When we imagine endings, we often picture abrupt conclusions, a final page, a closing curtain, a moment when everything simply stops. The universe rarely works that way. Instead, endings blur into transformations. Stars become remnants, galaxies become ruins, light becomes memory. One age quietly gives birth to another, and another after that. The universe continually reinvents itself, even as it grows older, even as it grows colder, even as it moves toward conditions almost impossible for us to imagine. So when we ask what will remain after trillions of years, the answer is not nothing. Far from it. What remains are the survivors, the patient objects capable of enduring where brighter things cannot. Black holes, ancient stellar remnants, frozen planets, fading galaxies, the quiet echoes of a once luminous universe. And beyond even that distant future lies an even stranger chapter, a time when black holes themselves, the great survivors of cosmic history, begin facing their own mortality. Because astonishingly, even black holes are not forever. And when the last black holes finally disappear, the universe approaches one of the most mysterious eras physics has ever imagined. A realm so distant in time that it almost feels disconnected from reality itself. Yet it may one day become the final destination of everything that exists. 16. The universe's last survivors. The universe is often described as a place of endings. Stars die, planets freeze, galaxies collide, black holes consume. Again and again, cosmic history seems to tell a story of disappearance. Yet hidden beneath all those endings lies another story, a quieter one, a story about survival. Because no matter how dark the future becomes, some things refuse to vanish easily. Some objects endure, some structures persist, some relics remain long after everything around them has faded away. And if we travel far enough into the future, beyond the age of stars, beyond the age of galaxies, beyond even the age of black holes, we eventually arrive at one of the most extraordinary questions in all of science. What will be the final survivors of the universe? Not the brightest, not the largest, not the most powerful, but the last. The objects that continue existing after almost everything else has disappeared. Tonight, as we gently reach the final chapter of this journey, let us drift into that distant future together. A future so unimaginably remote that every human civilization, every mountain, every ocean, every planet, and every star we know today belongs to an ancient past almost beyond memory. The first great survivors are the red dwarfs. Throughout our voyage, we have encountered them many times. And for good reason. These tiny stars are among the most efficient objects nature has ever created. Unlike massive stars that burn through their fuel rapidly, red dwarfs consume hydrogen with extraordinary patience. A star only a fraction of the sun's mass may continue shining for trillions of years. To put that into perspective, the universe itself is only about 13.8 billion years old today. Many red dwarfs alive right now have barely begun their lives. If the history of the universe were compressed into a single day, some of these stars would still be in the first few minutes of their existence. Long after galaxies stop producing new stars, red dwarfs continue glowing. Long after our sun becomes a white dwarf, they remain active. Long after entire regions of the cosmos grow quiet, these tiny suns continue illuminating the darkness. For unimaginable spans of time, they become the dominant stars of the universe, the guardians of the final stellar age. But even they are not eternal. Eventually, their fuel runs out, their light fades, their long vigil comes to an end. And when the last red dwarfs disappear, another group of survivors inherits the cosmos. White dwarfs, black dwarfs, neutron stars, the remnants of once living stars. Imagine a future universe filled not with brilliant suns, but with their skeletons. Countless stellar corpses drifting through darkness, most no longer producing light, most no longer visible. Silent monuments to an age when the universe was bright. These remnants may persist for periods so vast that ordinary numbers become meaningless. Trillions, quadrillions, quintillions of years. Time stretches beyond human intuition. Yet the relics remain, patient, unmoving, ancient. Occasionally, gravity brings some together. A pair of white dwarfs may collide. A neutron star may merge with another remnant. Rare flashes of energy briefly punctuate the darkness, tiny sparks in an otherwise quiet universe. Even at the end of the stellar age, the cosmos never becomes completely inactive. There are always small stories unfolding somewhere. Small survivals, small continuations. And then there are the black holes, the great survivors. If stars are the protagonists of cosmic history, black holes may be its final witnesses. Throughout most of the universe's life, black holes remain hidden, powerful, important, but relatively few in number compared to stars. As the stellar population declines, however, black holes become increasingly dominant. Galactic centers remain occupied by supermassive black holes. Countless stellar mass black holes drift through space. Many continue growing through mergers. Over vast periods of time, they inherit the remnants of entire galaxies. If you could observe the universe trillions upon trillions of years from now, black holes might be among the most prominent objects remaining. Their gravity still shaping their surroundings, their mass preserving ancient histories, their presence marking places where stars once lived. For an observer living in such a future, black holes would seem almost immortal. Yet one of the strangest discoveries in modern physics tells us that immortality may be an illusion. In the 1970s, physicist Stephen Hawking revealed something extraordinary. Black holes slowly evaporate. Not quickly, not dramatically, but gradually, through a process now known as Hawking radiation. Tiny amounts of energy leak away, year after year, century after century, trillion after trillion years. The process is astonishingly slow. A stellar black hole may survive for around 10 to the power of 67 years. A supermassive black hole can endure for roughly 10 to the power of 100 years or more. Numbers so enormous that they barely fit within imagination. Yet eventually, even black holes disappear. The greatest survivors of the stellar universe ultimately face the same fate as everything else. They fade. And when the final black hole evaporates, the cosmos enters a chapter unlike anything before. A universe almost entirely empty. Almost, because a few survivors may still remain. Elementary particles, electrons, photons, neutrinos, tiny fragments of reality continuing their journeys through nearly infinite darkness. The exact nature of this distant future remains uncertain. Physics itself becomes difficult to predict at such scales. Some theories suggest protons eventually decay. Others suggest they remain stable forever. The answer dramatically changes the fate of the cosmos. If protons decay, matter slowly dissolves. Planets disappear. Remnants disappear. Everything constructed from ordinary matter gradually falls apart. The universe becomes increasingly simple, increasingly sparse, increasingly quiet. Yet even then, something survives. Energy, motion, quantum fluctuations. The underlying structure of reality itself. The universe never truly becomes nothing. It merely transforms into something almost impossible for us to recognize. And perhaps that is the most beautiful lesson hidden within this journey. The cosmos is remarkably resilient. Its forms change, its structures evolve, its brightest chapters end. But existence continues finding new ways to persist. The stars give way to remnants, the remnants give way to black holes. The black holes give way to particles. Each generation inherits the universe from the one before. Each becomes the survivor of its own age. And as we sit here tonight, beneath a sky still filled with stars, it is easy to forget how special this moment truly is. We live during one of the brightest eras the universe will ever know. Galaxies fill the heavens, stars are abundant, planets are everywhere. The ingredients for life are plentiful. We are witnessing a brief but magnificent chapter of cosmic history, a chapter future observers may never experience. One day, all of this will become memory. The brilliant galaxies, the glowing nebulae, the warm suns, the crowded night skies. Yet the universe will continue, quietly, patiently, carrying forward the final survivors into epochs so distant that even time itself begins to lose meaning. And somewhere within that endless future lies a comforting thought. Nothing truly lasts forever, but neither does everything vanish at once. The cosmos lets its creations linger. It allows stars to shine long after they should, planets to wander long after their suns are gone, black holes to persist long after galaxies fade. The universe is, in many ways, a story about survival, a story written across unimaginable distances and impossible spans of time. And tonight, as our journey reaches its final destination, we can simply rest beneath the stars and appreciate that we are part of that story too. A brief moment, a small observer, living during one of the brightest chapters the cosmos will ever know. Thank you for joining me on this quiet voyage through the survivors of the cosmos. As the universe slowly settles into darkness, may these ancient stars, wandering worlds, and distant lights drift gently through your thoughts. Rest peacefully, and I'll meet you again on another journey through the endless mysteries of space.